Okay, now we're going to learn some basic logics. Let's start with AND logic. In ladder language, we'll have this logic, when two or more normally open contacts are placed in series. The virtual power will reach to output if and only if, first and second contacts are changed to close, in other words, their value are true or 1 in CPU program. This table show all possible states. The output will be on, only when all contacts are true. And this, is an instruction in function block language. Let me write this program in TIA software. Well, this is AND logic with two contacts in ladder language. Here we can change it to function block language. These are our two contact addresses which has been used in ladder program. This is an instruction in function block language. And this is assignment instruction which save result of our logic. If we need to have this logic with 3 inputs, click here, so I can insert another address such as I0.2. Okay, now I'm going to test it. We have learned how to test our programs with TIA simulator and force table. See here. Now the first and second input are true, but my output is false. Now let me active the last input. As you see, only when all inputs are true, and logic's output will be on. Okay, let me exit from simulation and come back to ladder language. You can do it from here. As you see, this is AND logic with 3 inputs in ladder language, which a contact with I0.2 address is added here. Let's learn another logic. We'll have OR logic when we have branches in ladder language. At this logic, if all inputs are false, the output will be off, in other states, the output will be on. And this is OR instruction in function block language. Another logic is NAND. Here are two normally close contact. In this logic, when both contactor are changed to open, the output will be off. This logic is called NAND or not N, because its output is exactly a inverse of AND logic output. Next logic is NOR. It's mean not OR, because its logic is exactly inverse of OR logic. In this logic the output will be on, only when both contact are off. Pay attention, OR and NOR logic instructions in function block are similar. But in the NOR instruction, we have these two circles. In function block language, these circles make inputs are inversed, and then pass from a logic instruction. As an exercise, let's see what XOR logic is. In this logic, the output will be on if and only if one of its input is active. Otherwise the output will be off. This is XOR logic in ladder and this is in function block language. Let's compare them. In the first line of ladder program, S1 which is a normally open contact and S2 which is a normally close contact are arrangement series. So S1 and S2 make AND logic. As you see, inputs of this AND block are S1 and inverted S2. Similarly, second line in ladder program and second AND block, say a same thing. As you know, in ladder language with parallel branches, we have OR logic. Thus we have a OR block in bottom respectively. Finally both of them, store the result of logic or RLO in H1. It's expected you can write and test this ladder program. Otherwise please back and see previous videos. Now let's do this exercise in function block language. Well, like previous videos, define a new project. When we open OB1 block to start programming, its default language is ladder. To change, here right-click and select FBD. Like ladder language, here are common instructions and on the right side, we can see a instruction list in function block language. Let me to insert two and block and define their inputs. Based on XOR logic, we must use this instruction to invert inputs. Now insert an OR logic and connect and block outputs to its inputs. Now insert an assignment instruction to store RLO. Well, we've made an XOR logic. If you change the OB1 block language to ladder, you will see XOR in ladder. Let me change it to FBD. We've used some FBD instructions. If you see carefully, here is XOR instruction in FBD. So let me use this instruction in next network which its inputs are S1 and S2. Like previous videos, let's test this program and use force table. As you see, when I change S1 and S2 values, the H1 and H2 output in both network are the same. So, we can use XOR instruction directly instead of first program. Well, this is end of this video. In next video we'll see other basic instructions.